So here is section 4.5, the concluding section on proving triangles congruent. So far, recapping real quickly, we have side, angle, side, 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 angle, side, angle, and angle, angle, side. So this one is for a more specific type of triangle, and it's called the right triangle. If I have a right triangle, and the hypotenuse, which is the longest side of the triangle, is congruent to the hypotenuse of another triangle, and one of the legs is congruent to another leg in the other triangle, then I can conclude that the two triangles are indeed going to be congruent. The right angle aspect of things forces it to be true. Okay? And so we're going to use this. This is called hypotenuse leg. So first off, you have to have a right triangle. And then I have to have the hypotenuse and one of the legs congruent to the hypotenuse and one of the legs in the other triangle. Then the two triangles will indeed be congruent. Okay? So that's the last one. Let's go do some problems associated with it. What information is needed in order to apply the hypotenuse leg theorem based off of what I have shown here? Okay, so here we want to identify what is needed to show this. Well, the hypotenuse on this triangle is a 9. So to do hypotenuse leg, the hypotenuse on this triangle must be 9. So PR has to equal 9. Okay, and this leg is PQ. The corresponding piece over here is LM. So then LM must be equal to 5. So this is what we need. So we need that. When I have that, then I can say that triangle LMN will be congruent to triangle PQR by the hypotenuse leg. So when you answer your questions, it's not about just giving me some small, quick, flipped off answer. You need to explain yourself in all answers. You'll be graded on how you explain yourself. Not that you have this. This is not enough. Write it all out to show me, answer the question that's being asked of you. For what values of A and B make the triangle pair congruent by HL? So looking at this, we have a bunch of little algebraic expressions. This is 4A. It's hard to see, you can tell. And so we're going to use this and this information to help us find A and B. So if the two triangles are indeed congruent, then the hypotenuses must be equal. So that gives me my first equation. That tells me then that 2A plus 7 must be equal to 15. And then the corresponding parts, these two parts right here, have to be congruent. Okay? And so then I have the other equation, 3A plus B equals 4A minus 3. So I now have two pieces of information and two equations from that. And hopefully from all this, we can figure everything out. So let's start with this one has 2 letters. This one has only 1. So let's start with this one. So subtract the 7. That gives me 8. Divide by 2. And that tells me that A is going to be 4. If A is 4, I can immediately plug it into this one up here to solve for B. So 3 times 4 plus B is 4 times 4 minus 3. So 12 plus B is 16 minus 3. And then by moving things around, we see that B is equal to 1. And we have answered then the question. Okay? When you're doing a proof of some type, you may find easier ways to do it. Just because I do it one way does not necessarily mean that I've done it the easiest way, the quickest way, or the only way. So when you do proofs and stuff, look at how you would find it. Walk through the proof first before you start jumping in and start writing everything down. Find your pieces. Identify the triangles you're actually trying to show congruent. Okay? Understand your problem before you begin. Walk through your proof before you write anything down. Okay? JKM. Trace it. JKM. So that is this big triangle right here. This is what we need to show. This one is congruent to LKM. So I need to show that this triangle is congruent to this triangle. Okay? So what options do I have available to me? Well, I have side, 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 angle, side, angle, angle, side. Okay? Things like that. All right? So how can I go about doing this one? Well, let's look at the pieces that I have. Do I know anything? Sometimes it might be useful to split the two triangles apart to help you see the pieces that you have. Here's one option I have available to me. If I take this right here and kind of like draw the triangles again, but separate them, this would be M, J, and K. And then over here, M, L, and K. And I know that those two pieces are congruent. But by looking at this very clearly, I can see easily that this side and this side are also going to be congruent because they are the same side. So now I have two sides. Can I get the third one? If I can complete the third triangle side to be congruent, then I can show them. Or I can look for this angle up here. Can I get that angle? Is it possible to get that angle? Okay. And I'm thinking, yes. Let's walk through it. In my picture over here, I notice that I have these little diagonals are drawn. This is now a 90-degree angle, which means these two triangles right here are right triangles. And I have shown already or given that the hypotenuses are indeed congruent. Since the hypotenuses are congruent, I just need a leg congruent. Well, look at here. This leg right here is congruent to itself, isn't it? So literally all I have to do is state that this side is congruent to itself. Okay? So by hypotenuse leg, these two triangles are congruent, which makes these two angles congruent. This side is congruent to itself. And so by side, angle, side, these two triangles will be congruent. That is our process right there. So let's go through that. We've walked through it. Now let's go write it all out. You are given that JL is perpendicular to KM. You are also given that JK is congruent to LK. Okay? So the one thing that you may not remember, but I'm going to write it out, so make sure you add it to your list of things that you can use as your tools for showing things for reasons. What does it mean why these two things are perpendicular? So if I'm given that, what can I conclude from that? That JL is perpendicular to KM. Well, perpendicular lines form right angles. Okay? So I can conclude that angle JNK is congruent to angle LNK because right angles are congruent. I can put right up in here that angle JNK and angle LNK are right angles because perpendicular lines form right angles. Perpendicular lines form right angles. Now they're congruent. I can say that KN is congruent to KN because it's the same side. I've now shown that these two triangles are congruent by hypotenuse leg. Triangle JNK is congruent to triangle LNK by hypotenuse leg. I need to get to this angle up here. Angle JKN is congruent to triangle LKN by corresponding parts of congruent triangles are congruent. So now I have this angle right here. KM is congruent to KM. It's the same side. And then triangle JKM is congruent to triangle LKM by side angle side. And so there you go. That is one proof. Again, doesn't mean it's the only way to do it. There is more than one way to do this. But that's how and what I'm going to be looking for. Tell me what you can follow, and you can write out your reasons. And just keep it simple. You don't need to worry about the mathies or anything like that. Just need to tell me why you know something to be true. Okay? And so we'll do more of these together in class.